Good evening, ladies and gentlemen. Welcome to the webinar series 2024. Tonight's topic is the future is electric vehicle 101. We have two speakers for tonight. They are Mr. Goh Se Seng, followed by Mr. Wei Kai Ming. Before I invite the speakers, let me share with you that you should have received the pre-reading materials that sent to you recently. You may also scan the QR code over here for those of you who have yet to receive the pre-reading materials. Okay, now I would like to invite Mr. Goh Se Seng to come to be our first speaker for tonight's webinar session. Mr. Goh, please.
Okay, good evening. I'm Se Seng here. Allow me to just self-introduce. Basically, I'm at the School of Electrical Electronic Engineering of Singapore Polytechnic. Okay, I basically lead a division of over 40 academics to drive technology development in collaboration with industries and research institutions in the various domains of electrical and electronic engineering. For myself, I'm also actively involved in our own SP autonomous electric vehicle projects. My current research interests are in machine learning for automatic car number plate recognitions and V2X technology for smart mobility. Okay, let me start with my segment of this webinar for this evening. Okay, allow me to give you a brief history of electric vehicle. Electric cars have been around since the dawn of cars itself. This dates back to the year 1830s, where the first electric vehicle was created. In early 1900s, electric cars were very popular among Americans. We find them in cities like New York, Boston, and Chicago. As many as 1/3 of the vehicles were actually battery powered. We also have electric taxi, dominating over the busy cities at the time as well. Electric cars, compared to the gas power competitors, they were much quiet, easy to maneuver, and they did not release any forward odor. The real competition came in the early 1900s when Henry Ford built the Model T car, which let the driver drive further and faster. And this eventually led to the downfall of the electric car. The Model T car was an affordable car made for the mass market. There were proper production line being assembled, used to assemble the car. And there were many cars of the Model T being made available for the mass market. Now these are some pictures of the early electric vehicles. At the top left hand corner, you see our first ever electric vehicles. So this was the electric vehicles in the 1830s. Then we have this picture of a German electric car in the early 90s. Another picture of an electric car built by Thomas Parker. Thomas Parker was an inventor. who actually held patents improvements in lead acid batteries and dynamos. And in the center here, we have Thomas Edison taking the picture with an electric car in 1913. Thomas Edison is an inventor famous for inventions like the light bulbs, the motion pictures. Okay, and the last picture here shows electric taxis, all right, in the year 1896 to 99. So these are basically how electric vehicles look like in the 1800s and the early 1900s. And you can see them to be quite different from the electric vehicles that we see today. I mentioned earlier that there was a decline of the electric vehicles in the early 90s, 1900s. Now this was mainly due to petroleum, alright, was very abundant and was very cheap. And there has been technology improvement in gasoline powered cars. So Henry Ford's vehicle was one example, and these gasoline powered cars can travel faster and further. In fact, by the time of 1930, there were no more electric cars seen on the roads. Decades later, however, things changed. We see oil prices went up sharply after the 1970s oil crisis. Air pollution became worse and worse with more and more gasoline powered cars. And electric vehicle came back to the attention. By the time of 1990s, we have many car makers coming out with their electric vehicles version. There were also hybrid electric vehicles being released, and this can serve as a better alternative as compared to pure EVs. So how do these electric vehicles look like in the 90s? We have some pictures here from General Motors, a Ford Ranger, a Toyota Prius, a Toyota RAV4, a Honda EV Plus. Now, Honda EV Plus was rather special at that time. Alright. Electric vehicles in the 90s typically were running on lead acid batteries. But Honda EV Plus was different. It was using nickel metal hydride batteries. In fact, there was something like 24 nickel metal hydride batteries within this Honda EV Plus. And another special thing about this Honda EV Plus is that it was not sold. It was only for leasing basis. So car owners who want the Honda EV Plus will have to lease from the company on a 3-year lease basis. And they are not sold. And there were very limited edition of this car being produced, something like only about 340. Okay, then we have the Nissan Ultra EVs. Again, there's something special about this. At the era when EVs were running on lead acid batteries or nickel metal hydride, this Nissan Ultra EV was using lithium ion batteries. Alright, it was using lithium ion batteries produced by Sony corporations. So it basically made itself rather different, okay, from the electric vehicles in this era. So to sum up, I would say that electric vehicles up to the late 90s, main characteristics is that they are using either lead acid batteries or nickel metal hydride batteries. Lithium battery was very expensive, and the electric vehicles typically have limited range, alright, 80 to 200 kilometers. And that is considered rather small, rather short range. Alright, and the battery lifespan also does not last long. And electric vehicles were very expensive. Okay, even after subsidies are given by governments. And they were in no way could compete with internal combustion engine cars in terms of both performance and price. In the 90s, Singapore Polytechnic already has a vision to go green. So we were actually involved in EV education and technology development since 1997. One of our significant projects at the time was this zero emission bus. We teamed up with the Trans Island Bus Service and a private company called Green Fuel Resources to actually convert a diesel engine driven bus into an electric one. Now, this diesel engine driven bus was a Nissan civilian electric bus. You can see it is a 19-seater bus, and it was basically converted to an electric driven bus. And we basically piloted it or put it on trial for 8 months. The collaboration with the bus company Trans Island was very important at that time. For the information on Southview, Trans Island Bus Service is basically today's SMRT bus. As you can see on the bus body itself, there's emphasis on Singapore first zero emission electric bus. Wordings like for a cleaner environment. So emphasis on zero emission already starts in the 90s. Now this bus was also featured in our newspaper at the time. So if you look at the interior of the bus, alright, the batteries used was basically zinc air batteries plus advanced lead acid batteries. For this bus, the diesel engine was being replaced with an electric drive system. Zinc air batteries has the characteristics is that the zinc itself is very cheap and it is in abundance. And zinc air battery is rechargeable as well. The Singapore Polytechnic experience of able to basically convert a diesel bus to electric bus basically starts from our experience of converting ICE car to electric. So this project was completed before the bus, and this basically gives us the experience on how to basically do the conversion for the electric bus. Now, Singapore Polytechnic, being an education institution, would like to really publicize sustainability to the main public. So at that time, we also produced a multimedia CD-ROM. Now, this was an era where CD-ROM was popular with school students. So we actually developed a CD-ROM in a period of 12 months, and that was back in 1998. So the CD-ROM itself was filled with educational stories, pictures, video clips, and text on electric vehicles that are used in the 19th and 20th centuries. And at the time, alright, we are probably the world's first multimedia CD-ROM that captured the history of electric vehicles. Apart from conversion of diesel bus to electric and production of multimedia CD-ROM, Singapore Polytechnic also ventured into solar electric vehicle developments. We built our first solar electric vehicle in the period of 1998 to 1999, and this solar car actually participated in the World Solar Challenge in Australia. Our solar car participated in the race where it stretches from Darwin in the north of Australia to Adelaide in the south. over a distance of 3,000 kilometers. Fast forward 10 plus years later, we built our second version of our solar electric vehicles. And we participated in the Shell Eco Marathon Asia. Following that, we participated in the World Solar Challenge again. And this time, we also received generous funding from the Singapore Power Group for our students and staff, as well as alumni, to participate in this race. So you can see how our solar electric vehicle basically evolved over the years. Now this was basically the challenger class of the solar electric vehicles. We decided to challenge ourselves further. The World Solar Challenge has another class of vehicle called the cruiser class. So in 2015, we decided to participate in the cruiser class of the World Solar Challenge. In the cruiser class, you will have to build a vehicle to minimally seat 2 persons. So the car itself will look more like an ordinary car, and you can see solar panels, all right, fill up the top of the car. And we have a very big team involved. So we have the we also have the cruiser class in the 2017 race as well as the 2019 race. So you can see that Singapore Polytechnic was very much involved in electrifications of vehicles. In the last 6 years, all right, we have also ventured into autonomous electric vehicle developments. Now we have this SAE, which stands for the Society of Automotive Engineers. So in the SAE, we have different definitions for the automation levels of autonomous car. First, we have the level 0. Basically, it is an ordinary car with no driving automations. That is level 0. Then we have level 1. The automation basically is in terms of the car able to provide steering or braking support to the drivers. For level 2, it is similar, except that the automation includes both steering as well as braking acceleration support to the driver. So that is level 2. For level 3, the car will be able to drive by itself, but under very limited conditions. And it is very, very particular about the conditions. It will not operate unless all the required conditions are met. So that is level 3 for automation level of autonomous car. Okay, we are level 4 and level 5, and this definitely the cars are much more autonomous as compared to the higher levels. So for Singapore Polytechnic, our journey into autonomous electric vehicle developments starts with the e-scooter and the go-karts. That was something like 5 years ago. Thereafter, we move on to phase 2, where we basically acquire an electric buggy. In phase 2, we basically spend efforts basically to convert the electric buggy to a drive-by-wire system. So what do you mean by drive-by-wire system? It is basically retrofitting the electric buggy so that it can be electronically controlled by the computer software. So we have achieved that in phase 2. So our vehicle was able to move over limited areas over our campus. It is equipped with cameras to see vehicles in front. It also has localization abilities using LiDAR sensors. In phase 3, we move to autonomous safety vehicles for campus surveillance. We expand the capabilities of our autonomous buggy. We have trained it to be able to navigate a large area of the SP campus. It is also equipped with vision system that is able to recognize number plates as is seen on the roads, and it is able to self-navigate. So this is basically our phase 3 of our autonomous vehicle. Okay, so this is basically our autonomous vehicle in actions. Now you may ask why I choose to show this video. Okay, this was taken during the period of COVID. I believe it was something like 2 to 3 years ago. Alright, it was an event where the Minister of Education, Minister Chan, visited SP, and we actually invited him to sit in our autonomous buggy together with our principal, Chief Executive Officer of Singapore Polytechnic. So currently, our autonomous vehicle development continues. We focus on 5G network integration. We focus on digital twin simulation. We focus on V2X, vehicle to everything. And we also look at solar power to improve the operating time of the vehicle. Our school here is also into industry collaboration with the industries, so that we can enhance our teaching materials with the assistance of the industries. So one example we have here is Inchcap and SP co-developed electric vehicle technology courses. So we have an MOU signing. We also have collaboration with SP Group, where they basically have EV chargers on the campus. This basically allows our students to see firsthand on how EV charging is done, and we also use this as a way, as a tool to teach our students. Singapore Polytechnic is also one of the parties in this multi-parties MOU signing on the National Vocational Certification Program called NEST, National EV Specialist Safety Course. So Singapore Polytechnic is also a provider for this course, where we focus on initiative to upskill and certify professionals in EV maintenance and servicing. We also have collaboration with Siemens, where we have the Siemens Digital Experience Center having software that allows us to do vehicle design. So this is basically how we strengthen our curriculum as well as our project works by working closely with the industries. Okay, now let's move back to electric vehicles. Okay, so let us take a look at the electric vehicles in the last 15 years from 2010 onwards. Basically, I would say that Tesla Motors has changed the face of electric cars. Tesla started with this Roadster model. Now this is basically a battery electric vehicles sports car. Thereafter, it produces a Model S, Model X, Model 3 and Model Y. Now Model 3 was an affordable model of the Tesla. while the Model Y was a crossover SUVs based on the Model 3 chassis. So electric vehicles produced by Tesla was able to run faster and can go for longer distance, right, than any other brands of hybrid or pure EVs could. Autopilot and AI technologies were also introduced in the electric vehicles. The success of Tesla actually encouraged the other automakers to basically build electric vehicles. So we actually see more modern EVs on the market. In Europe, we have the BMW i3, the Renault Zoe, the Volkswagen e-Golf. In Japan, we have the Nissan Leaf, the Toyota RAV4, the Mitsubishi i-MiEV. EV. In China, we have the BYD E6, the NIO, ES6, ES8. We also see a special type of EV called the fuel cell EV onto the markets, where we have models from Toyota, Hyundai, Honda, and Mercedes. So what are fuel cells electric vehicles? Fuel cell electric vehicles basically has a propulsion system very similar to electric vehicles, where the energy are stored as hydrogen gas in a tank on the vehicle. And this is converted into electricity by the fuel cell on the vehicles. Unlike conventional ICE vehicles, there were no harmful tailpipe emissions. In fact, what is produced from a fuel cell EVs are basically water and heat. So it is environmental friendly. Okay, so these are some of the modern electric vehicles. In the US, we have the Tesla, the Model 3. I'm sure you have seen this in Singapore roads as well. In China, we have BYD Han. Japan, you have Nissan Leaf. Europe, you have the Renault Zoe. Europe, you have the BMW i3s. So you can see modern electric vehicles available in different continents, and they are sold worldwide as well. Electric vehicles of today also has many smart features. So allow me to show a 3 minutes plus video on some of the smart features of a typical electric vehicles. So I pardon the audience here. This short video is recorded in Mandarins, but I will basically give a summary in English after the video is over. So let us watch this short video to see smart features in electric vehicles.
关闭全部车窗。
车窗关了。
好，就是在车内的话呢，我们可以去呼叫 Nomi 去实现一些功能上的一些操作。但是 Nomi 的话，它也有一个声源的一个分区控制，比如说。
Okay, so what I like to emphasize here is, okay, modern electric vehicles has features like using voice control. So this example you've seen here was using voice to close a window.
向我主驾呼叫它 ，Hi Nomi，
我来了。
帮我开窗。
好的。
然后它识别到是我主驾的指令，我这一个音区的指令，它只开我这一边的窗子，那其他窗子是没有变化的。 所以说您在车内的话呢，就是可以去呼叫 Nomi 去做任何的事情，除了驾驶之外的，比方说音乐、空调、车内的按摩、通风、车窗，这都是可以去语音来进行打开的。因为现在车内的按键是非常非常少的，所以说呢，我们也是希望通过语音的交互来实现一个这种在驾驶时的一个这种避免安全。
So you see that in electric vehicles today, you have many big panels, but very few, physical buttons for you to press. And with the use of voice control, it actually minimizes the number of physical buttons you will see in a modern electric vehicles.
隐患的这种情况，因为毕竟咱们开车的时候双眼要注视前方嘛，那如果你边开车边看屏幕，其实是非常危险的。所以说我们语音功能就是这样去产生的。而且还有一个好处就是，现在这个交互的速度和车内芯片的算力嘛是非常快的，那就是源于这个车内的一个这种车载芯片的算力。所以说呢，我们的语音交互速度和车机的反馈能力，其实基本上就是你一语即达，就可见即所得，所见即所得。包括说像我们的这个辅助驾驶的一些这种功能的操控，都可以在这个位置去进行调节。那这边是有个面容识别的，等于说呢，就是咱们每个人开车的时候，比方说一家子3个人都开车，不同的驾驶习惯，不同的座椅姿势，只要你调完之后，它就会记录到您目前登录的账号里面。那下次再上车，面容识别到是您的面容之后，它就会帮您去还原相应的一些这种习惯和座椅姿势，所以这就比较方便。
Okay, so this EV also is equipped with facial recognitions. Okay, because for electric vehicles or for a car, sometimes you may have different drivers. So when different drivers in the family drive the car, they may need different setting of the car seats or the adjustment of the mirrors. So with facial recognitions, this can become automatic. Family A comes to sit in the car at the steering wheel, it will adjust its car seat, its mirror accordingly. So these are one of the smart features the car has.
换电池方面，换电是吧？在这个位置，我们有一个闪电按钮，您点一下，然后这个位置就会去显示出我们这附近所有的这个换电的一个站点的位置。您看这现在全中国像上海这个城市是非常多的已经超过150座换电站。那我们举例子，像这个换电站，我们点进去之后呢，我们一是能够看到这个里面电池的储备，第二的话呢是能够看到多少人在排队。因为这个和平时那种传统的充电站和加油站是不一样的，因为往往您在去到这种充电站或加油站的时候，我们是不知道这个位置是否是排队的。那这个时候呢，我们都是纯线上实时更新的。一是我知道他什么时候排队，二我可以去估算时间。4个人在排队，那我们这边点击一下，它会自动导航去。
Okay, this is a new EV that you see in the video. Basically, allows it is charged by basically changing batteries. So this is not so typical in Singapore. So this new EV basically was sold in Shanghai. So there were basically many battery changing stations around. So the dashboard of this EV basically allows one to do planning. When the battery level drops below a certain level, it will basically alert the drivers and give suggestions to the driver. Okay, what is the nearest battery swapping station you can reach, and who is in the queue, and what type of batteries are available for you to swap to. So these are features that's available in this particular brand of EVs. So you can basically, based on the suggestions by the computer, move your EVs to the charging station that is most appropriate to the driver.
我们过去也要15分钟，那我们刚才看了一下，4个人换电，差不多也是15分钟能换好。那这个时候我直接过去，就不至于去排队了。所以说可以去很好的去控制一下我们自己的时间。第二的话呢，就是换电站的好处就是它会有很多电池的配备。有分这种标准续航的电池，也有分这个长续航的电池。 啊，那我们如果今天万一要去一趟跑个长途、跑个远途，那我们可以临时在这个 APP 里面去下单升级成这个长续航的电池。那我们只要去到换电站把这个电池换走，我直接就开到外地，一天只要花50块钱，也不用担心这个成本过高。因为未来不同规格的电池，虽然它能量密度不一样，续航不一样，但是电池包的一些尺寸、长宽高，这其实都是一样的，可以直接去做更换。所以未来换电的好处就是可充、可换、可升级。一是快，二呢就是可以去做升级。第三的话，我们就不用担心它的一个续航的衰减，因为凡是从我们换电站里面出来的电池，都是我们做过检测的，那寿命低于90%，其实我们自己就会淘汰。
Okay.
在呢。
Okay, so basically, electric vehicle has largely improved in recent years. The price of battery has dropped, and that basically corresponding leads to a drop in car price as well. There has been improvement in the range per charge. You can go longer distance, and improvement in battery technology has led to improvement in the lifespan of the batteries. Electric vehicles are integrated with intelligent control and autonomous driving technology. So electric vehicles are well adapted to become autonomous. It is basically a matter of loading in the right software, assuming that the necessary sensors are already present. In addition to the much lower maintenance and travel costs, electric vehicle is getting more and more competitive, and we see this as something that will continue, a trend that will continue. Now, in an electric vehicle outlook report of 2021 by Bloomberg NEF, it is estimated that the share of electric vehicle markets basically will increase from 4% to as much as 70% in 2040. Even there were no new incentive policies introduced by governments all over the world. I would say that to achieve carbon neutrality target by 2050, more policy support is still needed to accelerate the adoptions of electric vehicles. So what have we done in Singapore so far? In Singapore Budget 2021, we aim to have 60,000 electric vehicle charging points, both at public car parks as well as private premises by 2030. $30 million grant has been set aside for the next 5 years for EV-related initiatives, and we will increase the affordability of electric cars by narrowing the cost difference between electric cars and internal combustion engine cars. We allow the additional registration fee to be lowered from $5,000 to $0 for electric cars. We adjust the road tax for electric car so that the mass market electric cars pay similar road tax as internal combustion engine cars. LTA also has launched this EV common charger grants. This is to kickstart the installation of shared charging infrastructures in non-landed private residences. So LTA will co-fund the installation for 2,000 EV chargers, and this scheme is available until 31st of December 2025. Our government also proposes law for EV charging, where it requires new buildings to install chargers. So you can see that in Singapore, we have many initiatives to entice the public to adopt electric vehicles. electric vehicles basically forms part of the green infrastructure and mobility emerging domains in the green economy. There will be a demand for knowledge and skills in this green infrastructure and mobility, and we see a demand in this area, and we will provide more EV educations or EV related educations. So examples of skills will be related to electric vehicle and hybrid electric vehicle maintenance measurements or EV charger maintenance as some of the skills needed for the green economy. Now this slide basically sums up what we will expect to see in the years to come. In 2025, next year, every HDB town will become EV ready. We will see goals of 400 diesel bus being replaced with electric buses. In fact, 60 electric buses have already been deployed in 2021. By 2030, we will actually see 60,000 EV charging points, and half of our buses and taxis will have been electrified. In 2040, we will see all our new cars to run on cleaner energy. We use the word cleaner energy is technologies are developing. So apart from electric vehicles, there may be newer technologies that are equally clean. So that's the reason why, all right, we choose the word cleaner energy, which will of course includes electric as well as any other nascent technology that may come in the years ahead. By 2050, all right, we hope to reduce the maximum land transport emission by 80%. In Singapore, land transport is the third largest carbon emitter, third largest emitter. It basically emits as much as 15% of the total emissions of Singapore. So it is crucial to reduce the transport emissions so that the country as a whole will have a cleaner environment. So apart from electric, what other cleaner energy can we possibly have? Okay, one possibility is hydrogen. Can hydrogen be a key to sustainable transports? So this is, in fact, was even brought out in Parliament as a question to the Minister of Transports, and that was back in 2022. So basically, we already have hydrogen fuel cell vehicles, all right, where the vehicles will have power by combining hydrogen with oxygen from the air. So one good thing about such vehicle here is to refuel is very fast. You just need 5 minutes. It's like driving ICE vehicles to a petrol station to top up. So it's very fast. However, fuel cell technology currently is still not so efficient. To produce hydrogen, 70% of the energy is actually lost in the process of electrolyzing the water. Hydrogen also needs to be stored and distributed at low temperatures and high pressure. And again, this requires substantial amount of energy. So this hydrogen technology is still nascent, but we can see this as a possibility. So what's driving the electric vehicle revolutions? One, of course, is environment consciousness, government policies, as well as technologies. In the market, all right, we basically can have three different types of electric vehicles. In the diagram on the left here, we have the conventional vehicles, where you have a fuel tank. You go to a petrol station to top up the fuel tank. The fuel tank will provide fuel for the engine, and the engine will power the car. So the advantage of such a conventional vehicle is that it is easy to refuel, it has a long driving range, and it has a high speed. It is a typical car that most of us are driving today. However, emission is an issue for such a vehicle, and fuel costs are high in today's context. So that is the conventional vehicles. Then you have the hybrid electric vehicles. So for the hybrid electric vehicles, you will still have a fuel tank as well. You have an engine, indicated by the green color portion of diagram. You also have electric motors. So it is basically driven by the engines, while the motors are secondary. There's also a traction battery pack that is used to power the motor. So hybrid electric vehicles has the advantage that it is easy to refuel. It consumes less fuel consumption, and there's also less emission when it is driven by the electric motor. However, there's lesser power of such a vehicle, and it is heavier because of the additional parts, the traction batteries and the electric motors. Then we have the plug-in hybrid electric vehicles. So for the plug-in hybrid electric vehicles, same thing. You have the fuel tank, you have the traction batteries, you have the engine, you have the electric motors. The battery pack is larger. There's also a charging port that basically allows the vehicle to be charged externally. The main driver of this vehicle will be the motor itself, with the engine secondary. So again, such hybrid vehicles, you don't have to worry about couldn't find a charging station. It is easy to refuel, and you also consume less fuel, and there's less emission, especially when it is driven by the electric motors. This is also a very high price vehicle because of additional parts, and you don't have many models to choose from. Lastly, we have the all-electric vehicles. There's no fuel tank here. You have a very large battery, and you have a large motor as well. So this is environmental friendly. There's low maintenance because it has a very simple structure, all right, not many parts. The disadvantage is that we may be worried of not enough charging stations. The driving range may be short, and you couldn't go very high speeds. And also, the weight may be heavy because of the batteries. All electric vehicles, okay, one good example would be Tesla, all right, that make all electric vehicles. We also have brands like BYD or Blue SG, all right, being all electric vehicles. So in order to win the race to electrifications, number one, we have to overcome consumer range anxiety. We have to convince consumers that electric vehicles can go far. Technology has to improve such that vehicles can travel as far as internal combustion engine vehicles. we need to reduce the cost of the EVs. If you look at this chart here, in 2015, all right, battery electric vehicle cost much more than internal combustion electric vehicles. In 2025, the projection is that they are more or less similar already. Okay, they are more or less similar. Because if EVs are too expensive, then who will buy them? Thirdly, we have to look at the charging time. If you have to spend 2 hours charging, then it may not be so attractive to buy electric vehicles. So there must be a way to reduce the charging time. You go to a petrol station and top up, it can be just as long as 5 minutes or 10 minutes. So there must be a fast way to charge. So fortunately, we have available fast charger. In 1 hour, you can get something like 100 plus kilometers. Then we also have level 2 charger. Alright. So in 1 hour, you get about 16 kilometers. For fuel, of course, it is still unbeatable at the moment. In 5 minutes, I can get 500 over kilometers. But technologies are improving. Okay. So the other issue here is, apart from able to charge fast, the other issue here, at least locally here, is availability of EV charger. As you probably have observed, in most car parks, alright, you only have a few lots with EV chargers. So will you have an issue of, you have to fight or you have to wait for the charger to be available before you get to charge your electric vehicles? Of course, there's also a need to have some trade-off, because if every car park lot is to have a charging point, it's going to be very expensive. The electric capacity in the vicinity of car park also needs to be upgraded to allow this. So there are still many issues, but we are basically having steps moving ahead to make it attractive to own an EV charger, to reduce the amount of inconvenience that we have for EV charger. Okay, the key components of all electric vehicles. I will divide into 4 components. First, we have the powertrain system. Now, the powertrain system refers to a set of components that functions as power generation and transmissions for moving the vehicles. Then you have the battery pack, which is made up of multiple lithium-ion batteries, as you can see here. Then you have a battery management system, which will continuously monitor the state of the batteries, take necessary measures in case of malfunctioning of batteries. We also have the charging system, where you have a charge port here that allows AC or DC charging. Okay, we also have a control system, which comprises of several electronic control units to control the different subsystems of the electric vehicles. So this is basically the key components of the electric vehicles. Okay, my last slide here, is just to share with you some interesting facts of electric car. So first is, electric cars are not a new concept. So at the beginning of my webinar today, I mentioned that actually electric cars was available around the same time as cars was invented, and that was basically back in 1830s. Electric cars are no longer silent. People are now basically able to accept electric cars. They are getting more and more popular. Tesla basically has a new feature to keep pets cool if the pets have to stay in the car. Braking add miles to the range. For electric cars or hybrid electric cars, typically when a car brakes, it is basically able to generate electricity to the batteries. So it basically allows you to travel longer, alright, because of the regenerative braking of the car. So that's why we say that braking can add miles to the range. There are more electric car charging points than petrol stations. Okay, in Singapore, how many petrol stations do we have? I would say it is no more than 200 petrol stations. We definitely have much more electric car charging points. In fact, our aim is by 2030, we will have as many as 60,000 EV charging points. So this is an assurance that you need not worry that you cannot find EV charging points. The general public will basically learn to adapt. Okay, especially issues where people are hogging electric charging points after charging is finished. It's a matter of time, right? Where we learn to be courteous for each other, be more understanding, to move our cars away after charging is finished. You can also charge electric car at some petrol stations. In fact, you can power your house for electric car, although it is not common in Singapore. And in the United Kingdom, you actually have a new electric car registered every 9 minutes. So you can see how well received are electric cars. Okay, so with that, I would like to end my presentation here, where I'll invite the next speaker, Mr. Boy, alright, for the second half of the webinar. Thank you.
Alright, very good evening to everyone. So my name is Mr. Boy and I will take you through the second half of the webinar. So broadly speaking, I'm going to touch on 3 topics. Well, firstly, the risk of electric vehicles. Secondly, what to do in an emergency with an electric vehicle. And thirdly, I'll briefly touch upon an introduction to EV chargers. Now, what are the risks in vehicles with high voltages? First of all, we need to know what are the vehicles that has high voltages. Now, we all know that battery electric vehicles has a high voltage traction battery. However, hybrid battery vehicles will also have batteries with high voltages. The difference between these batteries and the battery in a normal internal combustion engine vehicle is its voltage, and more importantly, its energy density and capacity. In a normal combustion engine vehicle, we have a lead acid cell battery which is at 12 volts. For hybrids, we have batteries with voltage levels of between 100 to 200 volts, while in a pure electric vehicle, the battery can be up to 400 volts and even more for larger vehicles. So this brings us to all kinds of new risks which I'm going to address today. Now, traditionally, in an internal combustion engine vehicle, the main risk is its fuel, be it petrol, diesel, or even LNG. So these are flammable materials which can cause a spark and can cause fire or even explosion. Now with EVs, battery EVs, we have the high voltages and there are new risks that must be taken into account when you work on them. Now, I would like to add a special note for hybrid vehicles. So these vehicles have both internal combustion engine as well as a high voltage battery. So it is a case of a double whammy because you have the risk from the fuel as well as the risk from the high voltage components of the electric vehicle. And you must be able to take note of this risk and take care of this risk before you work on them. Now, what are some of the risks in vehicles with high voltages? Broadly, I'm going to cover the four biggest and most common risks in vehicles with high voltages. They are electric shock, an explosion or fire, the release of explosive or toxic gases and liquids, and lastly, a unique feature in battery electric vehicles is low noise. Now, what is an electric shock? Electric shock can occur when you come into contact with any high voltage components. So this does not include only things inside the electric vehicle, even in your houses, your offices, your factories. We are using electrical equipment on a day-to-day basis. All of this will have its danger and can cause electric shock to the user. So the risk of electric shock in an electric vehicle is actually nothing new because we as people in the modern society has been used to using equipment with high voltages, and yet most of us are safe as long as the equipment is in good working order. Now, what are some of the results of electric shock? Now, what is an electric shock? Electric shock occurs when there is a current flowing through the human body. And what can this cause? Firstly, it can cause a cardiac arrest. When current flows through the body, it actually disrupts the nervous system in our body. The nervous system is very important in sending signals from the brain to trigger the heart to beat. If this system is affected, a person may go into cardiac arrest, may lose consciousness, and eventually the heart will stop and potentially cause death. Another effect of electric shock, especially with much larger currents, is burns. When current passes through the body, it produces a large amount of heat, and this will actually cause burns to the human skin or muscles. And if severe enough, it can even cause fatality. The third one is not such a clear-cut effect of electric shock, but yet is something important enough for us to take notice of. When you get a small electric shock, you may lose balance and fall. Especially if you are working at a height and you fall, this can cause serious injuries from broken legs to even broken heads, which may eventually cause fatalities. I will now show you a video that will briefly describe the cause and effects of electric shock.
In cartoons, it's pretty easy to tell when somebody's getting electrocuted. Their skeleton flashes through their skin, their hair sticks straight up, and there's smoke everywhere, maybe some electric sparks radiating out from their body. But what actually happens when you are shocked is much less flashy and much more dangerous. Technically, and thankfully, most of the cases we call electrocutions are actually electric shocks. An electric current running through a body. The word electrocution comes from a combination of the words electric and execution, so it was specifically combined to describe death by electric shock. Whether an electric shock becomes an electrocution depends on the nature of the current involved. A current is the flow of electric charge carried by electrons or ions, and our bodies are pretty responsive to them because they use currents all the time. For example, tiny electric pulses from the movement of ions across membranes are what trigger neurons and allow me to move and be alive and talk to you right now. So when you're shocked and a much stronger current passes through your body, the tissues it passes through can overreact to that gush. In cartoons, it's pretty easy to tell when somebody's getting electrocuted. Their skeleton flashes through their skin, their hair sticks.
So sorry for the technical disturbance. I will continue from where we stopped just now.
Trigger neurons and allow me to move and be alive and talk to you right now. So when you're shocked and a much stronger current passes through your body, the tissues it passes through can overreact to that gush of electricity. In very mild cases, you might only feel a slight tingle in your skin, but as things ramp up, the current can cause mild to severe burns, muscle contractions, or even seizures because nerves and muscles are getting overstimulated. The amount of current that's flowing is measured in amperes, and a current of only 20 milliamps can cause someone to lose control of their diaphragm and stop breathing, and 100 milliamps can stop a heart. Now, more than 100 milliamps of current run through your phone charger, but touching its live wire won't kill you, not that I recommend you try it. It's not deadly because the amount of current in the wire isn't actually what matters. What matters is how much current gets into your body, and that's influenced by two things. The voltage, which is the difference in electrical potential that's driving the current, and your body's resistance to the current. Basically, if the current is like water flowing through a pipe, the voltage would be the water pressure, and the resistance would be like the narrowest section of the pipe, making it harder for the water to flow through. Your skin is pretty good at resisting current as long as the voltage isn't too high. It's a strong natural barrier to electric flow because it's dry and thick. It has way more resistance than the wires in your phone charger, so it experiences much less current. Of course, even when your skin resists the current, the energy from it still has to go somewhere, which is why heat is generated and why stronger shocks can burn you. Electricity above 500 volts is considered high voltage, and it's enough to punch through the resistant barrier of the skin and zap someone with enough current to stop their heart. In some cases, this is actually helpful. If the heart isn't beating right, the carefully targeted split-second 3,000 volt shock from a defibrillator can act like a reset button, allowing its muscles to fall back into a normal rhythm. But in a healthy person, stopping the heart is obviously very, very bad. When skin is damaged or wet, it has much less resistance. That's why hair dryers have those super strong warnings that using them in a bath can be fatal, even though a typical electric outlet is considered low voltage, about 120 volts in the US, 230 in Europe. So even though an electric shock can be mild and relatively relatively harmless, even low voltage power sources can pose significant risks, and high voltage sources are always super dangerous, which is why you should always be aware of potential shock hazards, and hopefully you won't ever experience the true definition of electrocution. Thank you for watching this episode of SciShow. If you really are fascinated by electricity, you might want to check out the episode.
Alright, so I hope the video gives you a little more knowledge about what is an electric shock and what happens to you during an electric shock. I would like to next cover the second risk of a vehicle with high voltages, which is explosions or fires. Now, this is nothing new to vehicles. As mentioned earlier, in internal combustion engine vehicles, the fuel can cause fire. Now, in an electric vehicle, where does the source of energy comes from? So this source will be in the batteries. Now, when there is a sudden discharge of this energy, either caused by a short circuit or due to the breakdown of the battery membranes, it can potentially cause an explosion or fire. Now, one thing that is unique about batteries is that it can catch fire even while it is stationary. In other words, even though a car, an EV, may be parked in the car park, if you see smoke coming out of the vehicle, that is a telltale sign that eventually it may catch a fire. And it's best to try to stop it at this point of time. Now, this is caused by something known as the battery thermal runaway. When a battery membrane breaks down, it will cause an internal short circuit in the battery. This will cause a large current to flow within the battery, producing heat and eventually causing a breakdown and a fire. Now, this fire is quite difficult to put out because in a conventional way of putting out the fire, you are trying to cut off either the heat or the oxygen supply. In this case, burning of the battery cells will actually emit its own oxygen and produce its own heat, further making the putting out of battery fires a difficult task. And this is something that users should be aware of. I would like to show you a video. So this is a parked bus. It is not moving, and you can see smoke starts to come out of the battery compartment of the bus before eventually turns into a large fire. Next, I would like to move on to the next series of battery electric vehicles. Specifically, this is again related to the batteries of the vehicle. Now, inside batteries, we have different kind of chemicals and liquids. So these are very important to store the energy in it. And it's made up of different kind of materials like lithium, cobalt, manganese, and others. Now, under normal conditions, all of these chemicals are contained within the body of the battery. However, if the batteries got damaged, for example, it is involved in a severe accident, or if there is inadvertent tampering of the batteries, then there is a possibility that you may cause these explosive or toxic gases and liquids to be released into the environment. Now, if someone comes into contact with these toxic gases or liquids, if it gets into the eye, it can irritate the eyes or worse, cause eye damage to the point of losing your sight. Coming into contact with your skin can cause irritation or even chemical burns, and inhaling these chemicals into the human body may result in deep breathing difficulties. So, if you are not familiar with the batteries, and if you see that a battery is damaged, please do not try to repair it yourself and leave it to the professionals who will know what to do and how to handle these toxic and explosive gases and liquids. The last danger of a pure battery high voltage electric vehicle is its low noise. Now, you may be surprised to find that why low noise is a risk. Isn't human world already filled with noise? Too much noise, in fact, some people say, and we will all love to stay in a quieter environment. So, in an internal combustion engine vehicle, when it is running, when the engine is turned on, it will definitely generate noise. However, in a pure battery electric vehicle, the only thing that moves is the motor, and this is pretty silent because there are not many moving parts. In addition, for hybrid electric vehicles, when the engine is not in operation, it is also quite silent. This is especially true when the hybrid electric vehicle is moving at low speeds, for example, in the car park or along roads with elderly pedestrians or young kids. So what is the risk? Now, most people who live around cities or towns with vehicles have been conditioned to hear out for noises, and they will instinctively know that there is a vehicle in the vicinity. They will then increase their vigilance and try to avoid the danger. In the absence of noise, there is a risk that the surrounding pedestrians may not notice that there is a vehicle nearby and will not have the vigilance, and also may not be able to notice the unexpected movement of the vehicle. let's say, for example, an EV is in the multi-story car park and is behind a person walking in the car park. The person may not be able to tell that a car is coming from behind. Fortunately, most car manufacturers have actually added in sounds when the motor is moving. So this is to overcome the problem of low noise. So next time when you are in an electric vehicle, if you hear a screeching sound when the car is moving, just take note that this is something that is intentionally built in to provide additional form of safety to people who are around the vehicle. So I would like to conclude with the saying that in overall, EVs are safe for use by the general public. Over the years, electric vehicle technology have improved tremendously, and safety has also been taken into account, and many more safety features have been added to electric vehicles over the years. Another thing that I would like to say is that over hundreds of years, humans have gotten used to internal combustion engine vehicles and think that they are safe. However, this is actually a human mind conditioning, and in fact, internal combustion engine do come with its own risks as well. And overall, an electric vehicle is no more dangerous than an internal combustion engine vehicle. So similar to an internal combustion engine vehicle, do not attempt to repair an electric vehicle yourself unless you have been specifically trained to do so. Otherwise, you may get into trouble with dangers such as electric shock or leakage of chemicals. In the next part of the presentation, I would like to share on what to do in an accident involving an electric vehicle. Now, an electric vehicle in its normal state is very safe. However, when there is an accident, due to the presence of the high voltage, there are additional dangers when you try to handle them. So when an electric vehicle gets into an accident, these are some of the things to take note of. One, are there any indications of fire? Two, are there any sparks, smoke, or vapor detected? Three, can noises be heard inside the high voltage battery? So these can be indications that there is a problem with the high voltage battery due to sparking. And this can eventually cause an explosion. 4, can you smell a pungent smell? If you do, there is a potential that there are leaks from the high voltage battery. 5, are there any liquid leaking from the high voltage battery? If you see any liquid coming out of the high voltage battery, please do not try to touch them, as they can be corrosive and can even be explosive. 6, is there any severe mechanical damage to any high voltage components in the vehicle? So if you see any orange components that are visible, do not touch them, as in an electric vehicle, any component that is color orange are typically high voltage components. And if they are damaged, then if you touch them, you may get electric shock. 7. Is there any visible damage to the high voltage cables? If you are able to see the metal conductor in the electric of a high voltage cable, please do not touch them, as they may still be potentially live. Touching them may result in having an electric shock. And lastly, is the temperature of the high voltage battery exceeding 80 degrees Celsius. If you notice that the temperature keeps increasing, there's a potential that the battery has already entered thermal runaway, and it's best to stay away from the vehicle at this point of time. Now, car manufacturers have also made safety precautions to ensure that even in an accident, the electric vehicle can still be safely, most users will still be safe. Now, one safety feature is that if the airbag has been deployed, it will automatically send a signal to cut off the high voltage system from the rest of the vehicle, and is totally disconnected from the high voltage batteries. However, even though the motors and the other high voltage components have been disconnected from the high voltages, the batteries will still have presence of high voltages. And one last thing to note is that do not proceed to touch the vehicle unless you can be sure that it is safe. Especially if you are unsure, do not do anything. Now, as every vehicle, be it electric vehicle or internal combustion engine vehicle, is designed differently, the way to ensure its safety is also different. Therefore, manufacturers have came out with a document known as the Emergency Response Guide. So this is typically only a few pages long. Since different vehicle models and different manufacturers comes out with different high voltage structure, different function, equipment, and again different technology. So when you are coming to a vehicle that has had an accident, it is important before you approach it to familiarize yourself with the vehicle, especially its safety features as well as where its dangers are, before performing any work after an accident. Otherwise, you do not know where are the potential dangers and how to overcome all these dangers. So vehicle manufacturers, be it Tesla, Hyundai, or BYD, will provide a guide known as the Emergency Response Guide. This is typically available on the internet. You just type in Emergency Response Guide followed by the model of the vehicle. You should be able to find this Emergency Response Guide. Furthermore, some vehicles will also have a special QR code, typically near the dashboard of the vehicle, to open the Emergency Response Guide on the smartphone. So typically what is inside this guide? Two things: where are all the dangerous components, where the batteries are, where the high voltage components are, and where any other dangerous parts of the vehicle are. And secondly, how to cut off the high voltage before approaching the vehicle. They may tell you that there is a certain cable that needs to be cut or a certain plug that needs to be removed to ensure that the high voltage components of the vehicle have been safely disconnected. Now take note that this guide is meant to be used only in an emergency and it's not meant to be a maintenance guide. For maintenance of vehicle, you have to refer to a separate document which will be much more comprehensive than the emergency response guide over here. For the last part of today, I would like to introduce you to electric vehicle chargers. Now, as my colleague has mentioned earlier, in a traditional internal combustion engine vehicle, it gets its source of energy from the fuels like petrol and diesel. Combustion of the fuel will ignite the engine to provide kinetic energy to run the vehicle. On the other hand, an electric vehicle gets its energy from this battery. However, the battery does not provide you with infinite amount of energy. After a certain distance run, the energy in the battery will be depleted. Now, in a normal hybrid vehicle, this energy will be topped up from either regenerative braking or by running the engine to top up the state of charge of the battery. However, in a pure battery electric vehicle, this battery will have to be topped up from an external source, and this external source is an EV charger. The purpose of the EV charger is to pull electric current from the grid and deliver it to the EV. This is typically done through a plug or is sometimes known as a connector. So an electric vehicle stores all this energy in the form of chemical energy in a large battery pack, which eventually will be discharged to power the electric motor. So to recharge or charge out an EV, the EV charger connector is plugged into the electric car inlet via a charging cable. Now, one thing to note is that EV batteries, or in fact all batteries, can only accept direct current power. However, in almost all countries, the electricity grid is in the form of alternating current or AC. So, one way or another, this electrical energy needs to be converted from AC to DC to charge up the battery. And the equipment used to convert electrical energy from AC to DC is known as a charger. Now, you may have heard people talk about AC charging and DC charging. So what are the difference between these two? Now, before talking about the difference, let's talk about the similarities. The battery charging is still in DC, and electrical energy needs to be converted from AC to DC. Now, in AC charging, the current flowing in the electric vehicle charger cable is in the form of AC. So how is the electrical energy being connected to DC then? In this case, you have to depend on the charger that is located on the EV charger itself. Now, the advantage of this is that you are able to connect into almost any socket outlets, and AC is easily obtainable. But the disadvantage is that the charging speed, besides being limited by the AC charger, is also limited by the onboard charger in a vehicle. Take for example, you have a car with a 3.7 kilowatt onboard charger, and you use a 22 kilowatt AC charger. So, what is the maximum amount of power you can charge? The answer is only 3.7 kilowatts, because you are limited by the size of the onboard charger. So, you may ask the question, why not install a larger onboard charger? Now, this will have an impact in the form of size and weight, and will render the EV less efficient by increasing the size of the onboard charger. So another solution will be to adopt DC fast charging. In DC fast charging, the AC power is converted to DC power in the charging station as well, and on the cable and the connector to the EV, you will supply DC power. The advantage of this is by putting the converter in the charging station, you are less concerned with the size and weight. Thus, you are able to install a much larger charger, and this can allow you to charge at a much faster rate. Of course, the disadvantage is that today DC chargers are currently still more expensive, and secondly, DC chargers are also limited by the grid infrastructure of supplying that much of high power to the electric vehicle. So in Singapore, our national public charging standard is TR25 2022, and in TR25 2022 we have selected two standards. For AC, it will be the Type 2 charger. This can allow for both single phase and three phase AC charging. Whereas for DC charging, TR25 has adopted the DC Combo 2 chargers. An optional standard will be CHAdeMO, which you may also find in certain charging stations around Singapore. So, in Singapore, all electric vehicles sold minimally will be able to accept the AC Type 2 charger in its inlet, and optionally, but increasingly, most electric vehicles will also be able to accept the DC Combo 2 charger to allow for fast charging. Now, how do you know that an EV charger is safe to use? So the authority that is taking care of this part of the industry is the Land Transport Authority, or LTA in short. In order to install an EV charger in Singapore, you must first ensure that the EV charger has undergone a rigorous criteria, has met rigorous criteria that has been set out in TR25. Now, how do you know that this charger meets all the rigorous requirements? So in order for a EV charger to be allowed to be sold in Singapore, it must first be type approved by the Land Transport Authority. Before LTA approves this model, it will require either the manufacturer or the importing agent to show that the EV charger model is able to meet this criteria by actually sending them to an approved laboratory for testing and obtaining a certificate. Once this certificate has been sent to LTA and LTA approves this charger, then it will be labeled as a TR25 approved EV chargers, and it will be issued with a sticker that you can see on the right. Now this sticker will be pasted on every EV charger that is sold in Singapore, and each model will have a unique sticker. So one model, one sticker. So 10 EV chargers of the same model will all have this same sticker. Now, take note of the sticker and see what it says in the middle. It says, please register the charger before use. Now, just by purchasing an approved EV charger doesn't mean you can use it immediately. For an EV charger to be allowed for use, it must also be registered with LTA. So EV chargers owners, so this can be for portable units, the owner of the portable units, and for units that are installed in the premises, the owner of the premises will have to ensure that the EV chargers purchased are registered with LTA. So, for this registration of these individual EV chargers, you must first ensure that it can be installed safely. So, owners are laymen. They do not know whether the EV charger has been installed safely. And thus, TR25 has a regimen of checklists to ensure that the EV charger has been installed safely. So first of all, the installation of the EV charger should be done by an authorized licensed electrical vehicle worker who will perform the installation, including the connection of the charger to the building or public electrical network, ensuring its safety. And there's another person who will have to certify the EV charger as well. This person is known as the EV charger specialist. So only after these two persons have checked the EV charger installed is safe by signing the checklist, then the owner can submit this checklist to LTA for registration, and upon successful registration, a registration mark like what you see on the right will be issued and must be affixed onto the charger. So as an EV user, if you drive to an EV charger and if you do not see this sticker, it means that this charger has not been approved and you should not use it. So installation of these EV chargers must be done only by a licensed electrical worker. EV chargers must be installed and certified by the relevant persons. And finally, the certification of EV chargers are done by the EV charger equipment specialists. Now, once you install and you use, how do you ensure that the EV charger is still safe after 1 year, after 2 years, or after an indeterminate period of time? To ensure the safety of users, TR25 has also come out with a mandatory periodic inspection and maintenance of EV chargers. So this is on the owners of EV chargers owners to ensure that their EV chargers undergo periodic inspection and maintenance. So under TR25, EV chargers are broken down into 2 categories. In the first category, which are restricted access, so these are typically for domestic houses. So in Singapore context, this will only include landed houses. Then you may ask, how about locations such as HDB car parks or condominium car parks? Aren't they also domestic premises? However, there's one key difference. In this case, the EV charger can be accessed by people who are not the owner, and thus it is categorized under the category of non-restricted access. Under the restricted access locations, the requirements for periodic inspection and maintenance is once every 24 months by a qualified EV charger equipment specialist. On the other hand, for non-restricted access, due to the higher usage levels and also accessibility by public users, the inspection and maintenance regime is more stringent. So in this case, every 6 months by an EV charger equipment specialist, and every 12 months by a licensed electrical worker of the appropriate grade. So I want to thank you all very much for coming to listen to the webinar tonight. I would like to now pass on the time to my colleague Dr. Tian to share with you some of the related short courses that we have. Thank you.
Okay, thank you to Mr. Goh and Mr. Bui for sharing with us on tonight's topic on electric vehicles 101. Before we close the session, I would like to share with you some of the related courses that's conducted by Singapore Poly relating to the topic of discussion for today. So as you can see, that we have fundamentals of electric vehicles 101, electric vehicles technologies and safety. These are the short courses that will be for those of you who are interested to find out in more greater details, right, on the electric vehicles. In addition, for further exploration, that my earlier speakers spoke about the evolutions of electric vehicles and solar cars that is being developed in Singapore Polytechnic. You would like to explore our autonomous and transportation systems, in short, it's known as ATS Hub. It is one of the 7 technology hubs reside in Singapore Polytechnic School of EEE. Over there are project works that's conducted jointly with industries for the interns and the staff to be involved, right, in various aspects of autonomous and transportation systems. So I'll pause here for a short while for you to take note of this. Okay, so before we close the session, you will receive an email with the recording link of tonight's webinar sessions and also the post-reading materials that we will send to you together. Last but not least, I thank you for your time, for spending about 2-hour sessions with us on the topics of electric vehicles 101. Good night.